Let's talk about byte storage. Every byte on a microprocessor has a unique address. So the addresses are 0 through the highest memory location. Let's say we want to store the number 1234 in hex. So you can see that's already a 2-byte number. It's a 16-bit number and it needs 2 bytes of storage. 12 is the most significant byte and 34 is the least significant byte. There's 2 common types of storage. They're called big endian and little endian. It has nothing to do with the American Native Indian. It's endian, E-N-D-I-A-N. So if we were storing big endian method, we would store the most significant bit at the lowest address, and then at address n+1 we would store the least significant bit. When you dump out the memory, it kind of looks like what you'd expect. You'd see 1, 2 followed by 3, 4, or 1, 2, 3, 4 hex. If you were storing a 32-bit number, or 64, it just keeps on going the same way. At address n, we have the 1, 2, and then we have 3, 4, and then at address n+2 we have 5, 6, and at address n+3 we have 7, 8. Those 4 memory locations, n to n+3, make up the 32 bits of storage, 4 times 8 bits. Little endian is most popular because Intel processors use little endian, and Intel developed the first microprocessor, so they kind of set the standard for us. Big endian is used by TCP/IP addresses, like if you have an address of 192.168.0.1, the 192 would be stored at the lowest address, and the 168 next, the .0 next, and the last address would be .1. The IBM 370 mainframes and the Motorola 68000s used big endian. Many RISC processors today, such as ARM, they support both big endian and little endian formats.